Yo, what's up everyone? This is LeetCode 33, search in rotated sorted array. We've done this problem in Python. Now we're going to do it in C++. So we have an integer array nums sorted in ascending order with distinct values. And prior to being passed to your function, nums is possibly rotated at an unknown pivot index k. And we basically have to find where that pivot index is. If it does exist, we return its index. Otherwise, we return -1. I think looking at the examples makes this problem statement make more sense. Basically, we have an array that's sorted initially, and then it gets rotated and what rotated means about a pivot index is basically at some point, it basically gets rearranged in a way where, like, for example, here, for example, it got pivoted right here, right? Like these obviously numbers were over here. Then it got pivoted such that those got moved to the front, and now we have this different sorted array, right? So basically the array got changed. But you have the same values, they're just in different orders now because it only got pivoted once at a specific index, right? And what this problem is asking, we have a rotated array now, and we have to find if this number target exists in the rotated array. And that seems kind of simple, right? Because like, oh, I just do a one pass and go through the array and find out where target exists in this new sorted array and then return the index, right? So that I know basically where target is. But the issue is we have to do an algorithm in O of log n runtime complexity, not O of n, right? And so that's where the issue comes in. And really, when you see this here, as well as seeing that it's sorted, the array is sorted, the first thing you should think of is a binary search, right? Because that's exactly what we want when we want to use a binary search, or when we can use it, is we have some sorted values and we can do it in O log n time, right? So when you have a problem that asks you to do something in O log n and it's sorted, you should consider if it's possible to use binary search. And sometimes the answer is yes, and that's kind of how you understand what approach you have to use. That won't be true in every case, obviously, but a lot of the times it will. For example, here, example 2, target 3 does not exist here, right? So we return -1. So yeah. So here's our example 1, right? And the way we're going to do this with binary search is we have our left pointer at the start, right pointer at the end, right? We're going to find the midpoint. So we're going to do L plus R divided by 2, right? So that'd be 0 plus 0, 1, 2, 3, 4, 5, 6. So 6 plus 0 divided by 2 should give us 3, right? That should be our midpoint. So 0, 1, 2, 0, 1, 2, 3, right? And here's what we're going to do. We need to check out, so this array is essentially split, right? Because with the midpoint, right, we have two sections of the array here, right? And we need to find out which part is sorted, right, so that we can handle our logic properly, okay? So what we're going to do is we're going to check, okay, let's check this value of the midpoint and the left pointer. If the midpoint is bigger than the left pointer, we know it's sorted, right? So let's check, is 7 greater than or equal to 4? Yes. So this is sorted. Okay, now what we're going to do is we're going to take nums of L, so 4, right? And we're going to take target, so it'd be 0, because again, we know this is sorted, and compare that to the midpoint. So left, mid, and is target in between there, right? Is 0 in between, right, 4 and 7? No, it's not. So now we know that target has to be elsewhere, right? So what we're going to have to do, is we're going to have to shift the left pointer to mid plus 1, right? Like that. Okay, so let's calculate this again, right? So we have 0, 1, 2, 3, 4 plus 6, which is 10. 10 divided by 2, right, is 5. So that gives us our midpoint right here. This is the 5th index. And we're going to do this again, okay? Is the midpoint, right, greater than 0 or greater than the left pointer? Yes, it is. So, and then we check, okay, is target in between that? Yes, it is. And since target's actually in between this now, we actually have to move the right pointer over now, right? To mid minus 1. So now these are equal, the left and the right pointer. And we would check it, we basically check again, and we'd find that this point here, the midpoint here, is equal to target. So we'd return this index here and we'd get the right answer. Okay, this is the same example except target is different, but the input array is the same, right? So just like in example 1, it's the same array, right? So so we would do 0, 1, 2, 3, 4, 5, 6, right? 6 divided by 2 is 3, so 0, 1, 2, 3, right? Our midpoint's right here. And again, right, we're going to check here. We're going to check here, right? It's sorted. Let's check. Does target exist somewhere in between there? No, it doesn't. So let's move the left pointer over here, right? We can delete this, get the new midpoint, which would be right here, right? This is sorted, but does target exist in between here? No, it doesn't, right? So in that case, the left pointer is going to have to move again to here, right? And then we're going to check here again, and we're basically going to check, is the target exists between the midpoint and the left pointer? No, it doesn't. So we move the left pointer over once again, right? And now we would break from our checking because the left pointer is bigger than the right pointer at this point. So we would break and we never return anything. We never found this target, right? So we just return -1, right? That's all example 2 is. So I think this problem is not too complicated, but you need to visualize it first. I think like trying to go into the code right away can really throw you off. So I'm not even going to do example 3. It's so simple. But yeah, that's basically the problem, okay? It's not too complicated. It's just very difficult at first. If you try and like write code without visualizing it, it can be a little bit hard. So here we're going to make sure we're going to enter the while loop, and our condition, right, is that the left pointer has to be less than or equal to the right pointer, okay? So remember, we're going to get the midpoint, okay? So we're going to say int mid is L plus, and we have to do R minus L because we're in C++, right? And we do not want any overflow. So we found the midpoint. You could do L plus R divided by 2 if you were in Python because overflow is not really an issue, but in C++, obviously, overflow is an issue. I guess you can use like long or something, like whatever, but I'll just use an int and do it this way just to be a little bit safer from overflowing. Since our ints can only be so big, right? So anyways, we calculate the midpoint, okay? And now we need to first check, okay, is the midpoint equal to target, right? So we're going to say if nums of mid is equal to target, well, we can just return the index, right? Because we found what we're looking for. We're going to return mid, okay? Now, else if, and this is where we do the checking, right? Remember, this is now where we're going to do the checking where let's say L is here and R is here. We're going to check, okay, is this bigger than this, right? Just so we know if it's sorted, right? What portion of the array is sorted, given our midpoint, right? So we're going to say if nums of mid is bigger than nums of L, we know it's sorted, right? So if this is the case, 7 is bigger than 4, we know it's sorted, right? So now let's do this part here where we check, we have these boundaries, and let's check if target exists within those boundaries, which is what we're going to do, right? I'll write some comments here. So we're going to say check if target exists within boundaries or not. So we're going to say if nums of L is less than target and target is less than nums of mid, right? If that's the case, right? So if target exists in between here, we need to shift the right pointer over from, and sorry, I said R right here. This should be midpoint. Our right pointer is right here. So if target exists here, we need to shift the right pointer, right? Because we care about target being in here, so we need to make sure we are checking the appropriate things so we can actually find what index target belongs to, right? So we're going to say R is equal to mid minus 1, right? Else means that basically target's not in here, so it must be potentially over here. Not guaranteed to be, but it's potentially over here, so we shift the left pointer over instead, right? So we're going to say L is equal to mid plus 1, right? Now, nice. Now we also have an else statement here, right? And this else statement is basically where we fail this check. So it means nums of mid is not bigger than and this should be bigger than or equal to. That means nums of mid is not bigger than or equal to nums of L, in which case the right portion is sorted. So let's check there and see if target's there, right? And it'll just make our logic a little bit easier to handle on what pointer to shift where, right? So here we're basically going to say if nums of mid is less than or equal to target, and target is less than or equal to nums of R, we're basically checking the right portion now, right? And we're going to say if target exists in there, then we have to shift the left pointer over there, right? So we're going to say L is equal to mid plus 1. Else, that means the target potentially exists in the other side, which is not sorted, in which case we're going to say R is equal to mid minus 1, right? Now, when we exit this while loop, right, it means we never entered this if statement and returned anything. And let me just put this like this, just so you're aware that this is part of the if else statements. If we exit this while loop, we never returned anything in the if statement, right? In which case we just want to return -1, because if we exit the while statement without returning anything, it means that target does not exist in nums, so we never found an index for it, right? Make sure I include my semicolons. Okay, that runs. And this should submit perfectly. Nice. So yeah, this is the code, right? I'll zoom out a little so I can have it all kind of on the same screen, but yeah. I really don't think the solution is too complicated. I think it's just very hard to do if you don't visualize it first. So, you know, if you're so confused, definitely just think of some examples. I mean, you can make up some examples and it'll tell you what the expected answer should be, right? If you mess around with the test cases, like make up some array and some target. And, you know, just go through. I mean, I don't think that would help you anyways, because it's just returning whether the target exists in the pivoted array. If the target exists, then you return the index. But my point is, if you're confused by what we're doing here, just go through it by hand using some example you can make up, right? Or just these examples like I did. I think when you visualize it, this problem really isn't too difficult. But coming up with it on your own, like coming up with, okay, I got to use binary search, I'll give it to you. That might be a little bit, hard at first to come up with on your own. But in terms of the actual logic of how we're doing it, shouldn't be too difficult. But yeah, I hope this helped, and I will see you in the next one. Peace out.